Example 2. Graph each linear function using the slope-intercept method. So to sketch a linear function using the slope-intercept method, first thing we need to do is we need to identify the slope and y-intercept. Very important. It's almost right in the name. We're going to plot the y-intercept, and then we're going to use the slope to find a second point on the line. So remember that we're going to start off with the y-intercept, and then we're going to use our slope definition. Remember to draw a line through the points, and remember the arrowheads. We have to remember because this is a continuous graph. So allow me to consider the function y is equal to x plus 3. So my slope, first step, my slope. My slope is 1. My y-intercept is 3. My slope was m, y-intercept was b. So my y-intercept, I ask myself, where does this function cross the y-axis? Or where does it intercept the y-axis? And somebody told me 1. So I put a little mark there at 1. Oh, pardon me, incorrect. Where does it intersect the y-axis? And that is actually 3. And now my slope is 1. So vertical change over horizontal. So I simply go up 1 unit, go over 1 unit, and I have another point right there. Take this down. How many points do you need to graph a line? 2. So you just draw a line between those 2 points, and that's the line that we're talking about. Me personally, I like to get points farther apart. So there we are, there's my line. Make sure I include arrowheads. Here we are. And if I'm drawing it correctly, from one point to the next, I should have a slope of 1. There we have it. There's my graph. It wasn't so bad. Let's maybe tackle this. B. So I'm going to identify my slope, which is m. My b is my y-intercept. So my slope is -1. My y-intercept is 4. Remember, m is the coefficient in front of x. Here it says negative, but it's going to be -1. So I'm going to graph my y-intercept, and that is 4. My slope is -1. So I have a vertical change of 1 over a horizontal change of +1. So it means that as I go left to right, I go down 1 unit in my y over 1 unit in my x. How many points do I have? Indeed, I have 2. There. Make sure to put arrowheads on the bottom. So I'm just going to talk about having a slope of -1. I find having 2 points very close together hard. It's just not pretty. So did you know that 1 can be thought of as -5 over 5? So what I can do here is I still have a y-intercept of 4, but I can count down 5 units. My vertical change would be -5, and my horizontal would change, go over to the right 5 units. So I also have another point right there. There. I don't have a ruler. It's one thing about drawing electronically. Don't be afraid of this question. My slope is 5 over 3. My y-intercept is 1. So I'm just going to simply draw my y-intercept, boom, right there. Now my slope, remember, it is a measurement of my vertical change over my horizontal change. So if my slope is positive, I'm going to go up 5 over 3 to the right. So I literally count up 1, 2, 3, 4, 5. 1, 2, 3. I have another point. Those are my 2 points. So really, all I have to do is connect the dots. Wasn't so bad. It was actually easier to have a fraction for a slope, I find. All right. I'm just going to maybe take 1 or 2 here and there. So my slope here is -1/4. That means since 1 is negative, I go down 1 unit over to the right 4. My y-intercept is -2. So I'm going to graph my y-intercept. Next thing I'm going to do, I'm going to count down 1 unit in the y over 4. There. And I get my second point right there. Ooh, this isn't looking so good because my line isn't straight. I apologize. I really do wish I could draw with a... No. Let me try that again. Nope. Getting better. There's my line. Just make my points very, very obvious. Please use a ruler. I feel like we've captured this. Now, ye gads, maybe I'll do this question here. All right. So I have a slope of -6 over 5. That means I can go down 6 units and over 5. Now, the negative direction, now I'm just going to write out slope, or just fractions. -6 over 5, you can think of it as -6 over 5, or you can think of it as 6 over -5. Now, some of you got dinged that you can never have a negative in the denominator when you're writing a final answer. True, but when you're working with slope, it might help out if you're in a tight spot. So, for instance, my slope, now I'm going to figure out my y-intercept. My y-intercept is -4. Okay, so I graph my y-intercept, and perhaps I'm going to use this method to graph. So I count down 1, 2, 3, 4, 5. I can't count down 6 because I go over the graph. So really, although my graph says a slope of -6 over 5, I'm going to try to think of it, only think, never write it as 6 over -5. So that means that I go up 6, but I go to the left -5, right? The vertical change is +6, but my horizontal change is 5 to the negative, 5 to the left. So I simply count up 1, 2, 3, 4, 5, 6, and I count over to the left 5 units. 1, 2, 3, 4, 5. So here's my second point. There are my 2 points for my graph. And there. I have arrows at the end, making sure I'm not losing any marks. Last but not least, so here, slope. My slope is 4, my y-intercept is 5, and look where I put my point. Boing! At my y-intercept is 5. If you want, you can treat your slope as 4 over 1 in the positive and to the right, but what's going to happen is you're going to be off your graph again. Instead, what I may try to do here is I'm going to write my slope as positive 4 is negative 4 over negative 1. Right? A negative divided by a negative is positive. So really, I can move down 4 units and left 1 unit. And I'm right here. There's my other point. And moving from this point here, my purple point, up to my pink point, you're probably wondering, like, what is my slope? Well, your slope going from purple to pink will be 4. Maybe you don't like this. Maybe you want to think of it as, well, where would my point have to be before so that I could have a slope of 4? That would have to be right here. There. Magical. All right. One more video, and then we are done.